Welcome everybody, my name is Dávid Halász. I'm going to talk about my research at the university about human-like behavior in autonomous systems. We're going to learn more about what this means. If you read the abstract, then you probably have some clue what is going to happen. At the beginning, I would like to give a little bit of memory of my former supervisor, who you see on the picture sitting. She would be sitting here, but unfortunately, since December, she's no longer with us. I'm really grateful for those 3.5 years that I could be working under her on the PhD. I would not even start the PhD. I chose the supervisor, not the subject. I chose the supervisor, not the university. She would be probably here. Unfortunately, she cannot because she's no longer with us. If you haven't heard about her, her name is Bára Bűnová. She was the founder of Czechitas, very famous person in the Czech Society for Women in Technology. If you don't know her, she's on Wikipedia. Look her up. Let's remember her. She was amazing. Thank you. So, my name is David. As I said, I work for Microsoft on the side, but my main gig today is to talk about how I do research at the Faculty of Informatics at Masaryk University in the Lab of Software Architectures and Information Systems. This is my last semester, ideally at the PhD, but it's going to slip a little bit, so 4th year. Anyway, so I'm David. I live in Brno. I have a hedgehog. Her name is Mina. She's amazing. No more pictures of her. We're going to go into what are autonomous ecosystems. You probably know about autonomous systems, autonomous vehicles, robots, drones, airplanes, blah, blah, blah. Ecosystems are when you put them into a context. Let's say you have a smart city with vehicles that can be called as an ecosystem, or if you don't have a city, just a few vehicles on a highway, that can be also interpreted as an autonomous ecosystem. Or if we take it further, what, let's say, Amazon does with the robots in the warehouses or in factories, and what some of my colleagues work on is a swarm of drones when they fly together. What's common about all of them? That they all eliminate human factor. There are no more humans in autonomous ecosystems. That's the point, right? Don't quote this on like stuff where it can be shown me as in a negative picture where I want to kill people. I don't. So we're going to do this with not robots or not drones. We're going to talk about autonomous vehicles. And let's imagine a world where there are no human drivers. There are only autonomous vehicles. What does it solve? There are many bad stuff about humans, right? They make mistakes. They don't know how to drive, some of them. They are hard to be predicted. Slow reaction time, especially they are after each other, then the reaction times add up. So there are a lot of problems with humans when they drive, obviously. Everybody knows that. There are also some good stuff which humans do when they drive. Surprising, but they actually do. They have a moral compass. They know how to distinguish right from wrong. Machines cannot really. There are like traits like honesty, transparency, fairness, suspicion, that we're going to talk about more. Social relationship, they can form trust between each other. That's probably the most important when you drive. If you don't trust the guy in front of you or the person in front of you, you're going to be more careful. And they can also, as I said, they can adjust their behavior based on that. So we're going to get into this problem where we build electric vehicles and make them autonomous. And when we eliminate the human factor, we fix some problems, we solve them, but we introduce some new. You just saw them. And quick question, I see some familiar faces. Who was here last year? Hands up, please. AV technicians don't count. Anyway, I was here with my colleague Dasha. She couldn't make it today, otherwise we would have been having the talk together. We were talking about fair behavior in autonomous systems, how we can reintroduce fairness that humans can do but machines cannot. Check it out, it's a video if you want to look at it. Now we're going to talk about, instead of fairness, oh, sorry, go ahead. Takes you to the page of last year's DevConf, which is not available on the website. It's a complaint. So I'm going to bind some stuff on this, but now you can get ready for, instead of fairness, we're going to have carefulness, or as we call it in academia, it's adaptive safety. So let's imagine a human reaction. Pedestrians, not cars. So I walk on the street and I meet a stranger. My brain creates a model of that stranger. Believe me or not, this is how it works. And your brain simulates this stranger in a current situation and in possible situations. Let's not talk about fantasies, like real-world scenarios. If you have negative simulation results, you will be careful. If the simulation results are not matching with what happens in reality, your model is wrong, you're going to be careful. Something like this. You go on the road and you have an imagination of the other person you meet. But we were talking about that we eliminated human drivers, right? So what would happen in an autonomous ecosystem in an ideal case? So I swapped the slides by accident, but something like this. I'm going to go back. Blue and gray, please remember which is which. So blue autonomous vehicle gets close to the gray one, and the gray one sends its model, its simulable model, a digital twin, to the blue one. We can call it honesty. Hey, this is me, this is how I behave, you can simulate it, you can have some results based on that. You do the simulations with your blue AV. The simulation results are checked against some safety rules, general rules of traffic, whatever. If the model doesn't do anything dumb or stupid, then these simulation results also with a delay are compared with reality, same as with the humans. We can call this trust. How much is the model of somebody compliant with its honesty in real life? You can also get simulation results from others. We call it reputation or external trust, and make decisions based on a value that you aggregate together. So again, you see another car, you start thinking about the other car, because what cars think about, they think about each other. And based on your imagination, you see that the logos of the cars don't match. There might be some compliance issue between the two, so they might not trust each other. But I keep talking about trust for people who probably are in computer science and IT, and you might not know what trust is, because most of the people think about trust as something like cryptography trust, where it's like something binary, like you trust or not, 100% or 0%. We did an extensive research on what trust is, and it wasn't fun in the first year, I can say to you. There are various aspects of trust from various fields. We squeeze them together into this picture. There is direct trust and indirect trust. I was talking about trust that you experience, trust that others experience and gossip about. Then you have some kind of context information about how vulnerable makes it to you if you don't trust or trust. Basically, what I can say to you as the definition of trust, everybody has it differently. We went with trust is a relationship, period. Trust is a relationship under the shadow of vulnerability and security, where you have to make decisions based on. So we were thinking about how to express this trust. As I said, binary yes or no is not good, so we came up with something called trust score. So we take simulation results, some predefined scenarios as the fantasy of the person. We calculate the difference between the real-world events that happen with the predictive simulations as I was talking about, and we get the reputation information from central authority. Let's say the city can certify you a vehicle and you can trust it or not, or you can have some cameras, speed cameras, roadside units on the road that you can have higher value of what reputation they give about other vehicles, or you can have full gossiping. So imagine a classroom of a high school with kids, and they start gossiping about each other. Same thing on the road. We are trying to figure out how this would work with vehicles. Basically, it's just a percentage. You squeeze all these informations together, and you have a spectrum from 0 to 100%, how much you trust another actor of your autonomous ecosystem, in this case, cars. Was it followable so far? Okay. we can go into implementation details in questions later. We have that figured out. But what I'm mainly working on is a software architecture, because I work in the software architecture laboratory. It's called the adaptive safety architecture for carefulness, for people who are not from the field. Basically, it looks like this after 3 years of refinement stuff, what I was talking about. Basically, an autonomous vehicle right now is a bunch of sensors, a safety module on the right. It's a bit more gray. It doesn't really look well on the screen, but the baseline safety module and the actuator. So you can imagine these 3 boxes connected to each other. We are extending this with some additional stuff. So there is things around trust, and there is things around safety. Take trust granted, this is somebody else's research, and I'm not going to take credit for it. We get a percentage from the trust manager based on simulations, compared results, generated scenarios, fantasies. And you have the digital twin management that has the thoughts about the other car that you saw in the picture. Based on that, you get a percentage for each vehicle in the network. My part is you have the baseline safety module, and you can adjust it to have adaptive features that are triggered based on trust. So the idea is that there is an existing safety module, and you adjust it to be trust-driven, have multiple instances for multiple cars that you interact with, and in the middle there is an aggregator that decides which one to use, basically. So we are backwards compatible with the old system. I'm going to go back. We are backwards compatible with the old system. We can go back to the baseline, but if we want, if we support it, we can do more adaptive, more agile stuff. In our view, this is how the baseline safety module works. It's basically an endless loop that checks if crash, then don't. Basically, all autonomous vehicles work like that. If you don't believe me, check any other meme site. I'm pretty sure they're all there. On the right, you see a more high-level example of switching lanes, I think. That was done by some students. Basically, every safety module existing one can be moduled with a decision tree. Decision tree as in machine learning, but not used for machine learning for classification, but for making actual decisions based on some conditions. Yeah, you can see it there. The idea of these is that this can be extended with trust-based decision nodes. So there is a method that I created that you can apply to it, and you can get into a more complex node based on some methodology that will give you trust-based decisions that provide you safer behavior in autonomous ecosystems based on how much you trust other vehicles. Not that important, you get the high-level concept. And of course, I'm doing PhD, I need to do validation. So thank you very much for the CHESS project, which is a Czech, Estonian, South Moravian, Estonian Cybersecurity Excellence Hub that sponsored my travel to Estonia, where I presented this idea, and I was meeting with some young professionals who were helping me validate this in real-world cases. So we actually had a model of a safety module of a vehicle, and they were adjusting it with the method, and they were giving feedbacks of it, and we had good results for it. Then, there was a talk from last year. If you were here, you remember we were talking about validating that thing with simulations. And we had some master student who was reached out to us after the talk, who was interested in doing the validation, and he actually did it using this tool. It's used for traffic simulation called Sumo. And the framework he implemented was picked up by another student who created simulations for me for the adaptive safety features. Unfortunately, I wasn't able to put any animations about this into the slides, but basically this traffic simulation tool was able to validate and say that the adaptive safety features aren't just safer, you'd have less incidents, but it's also faster. Because if you trust other vehicles, let's say merging into lanes, if the trust is high, you can do it much, much faster at higher speeds. So basically, I have everything for the thesis. I'm still waiting for some papers to be published. It's going to be named like this. And hopefully, we can have some questions, some discussions about it. But before that, I would like to have a special thanks to my students, Rado and Richard, my other supervisor in Belgium, Dimitri, and Dasha, who was doing the talk with me last year and couldn't be here today. Thank you. Please have questions, because I was probably too fast. Magnus?
I have a question about the digital twin.
Yes?
What would the digital twin contain? Would it contain things like maximum speed of the vehicle or acceleration factors, turning radius, and stuff like that?
He's just showing me repeat the question. So the question was, how does the digital twin look like? My personal answer is, I don't know, I don't care. The real answer is, we are working on that with our team in the lab, and one of the other students is dealing with this. A high-level description is, it's a group of safety guarantees. It's a bunch of ifs, basically. It can be a model of the vehicle completely as well. But if we want to have it efficient, we probably don't want to have a full model. Basically, anything that can be run in a simulation from the perspective of the architecture. But ideally, I would like to go with the bunch of ifs way. Did I answer a question? Okay. Yes?
Is there a kind of a bias problem when establishing the trust relations? And then kind of you trust the more trusty vehicles, then they become safer, of course. The other vehicles that are not trusted as much become unsafer. You like shift the trust values yourself just by engaging with the other participants in traffic, if you know what I mean.
Yes, I know what you mean, and I'm going to repeat your question. And if you don't, if you think I didn't understand because my question repetition was wrong, please wave your hand. So he was asking about if there are any bias, if somebody, some group of vehicles will gain more trust and some other group of vehicles will gain less trust, and there will be some imbalance in the network. Did I get it correctly?
Yes.
Yes. So there are mitigations for this in the trust research that I didn't do, but what I can say is the trust is evaluated real time. So it's always checking the past experience, and it's a spectrum. So it's not absolute 1 and 0, but some percentage. So the margin of error is not that high if you have somewhere overshot or undershot somewhere. And it can be corrected based on the other behavior of the vehicle. Basically, the idea is that the aggregator function should be good enough to not overshot. So that's where we could compensate it. And ideally, the reputation shouldn't be the biggest factor into combining the trust values. Let's go to the implementational details. Basically, when you do the simulations, you create a tree of various outcomes. The simulator runs through that tree, draws some path on the tree, and the real-world scenario is following that path. If the path is following by all the nodes, it's 100%. If it's less, then you have some deviation. You can calculate it with percentage, and that's the main factor. Go ahead.
So what is the hysteresis on losing the trust towards not so losing the trust? Let's say you have a vehicle which you lose the trust because it's doing some not so nice driving skills, and then the trust level goes down.
For that vehicle.
How much is, like, can you set the hysteresis for that when it goes back?
Yeah, so the question was about how much is the trust changes and how much is it dropping based on bad behavior. These are parameters that in our research not necessarily we're going to do. What we can do, I believe that these numbers should be configured by a higher authority, let's say the city authority, because these numbers might be different in different driving cultures, even for autonomous systems. They have driving cultures in autonomous systems, by the way. Look up, you will not be able to sleep for 2 nights. Tried. So basically, our solution is to expose the knobs and give it to other researchers. But I guess it answers the question. Matthias?
In your diagram for the line merging, I believe, you had some values to the decision tree.
Yes.
How do you determine those?
Yeah, so so in the diagram, this one you mean. In the diagram there were some values in the decision tree, And the question was, how did I determine them? I was totally despotic and arbitrary. No, these are from some students. And we had some parameters of the trust system where we were working, and these were the ones that they found as safe. Basically, it's part of the methodology of some preset values for various situations that come from trust researchers, and it gives you this tree based on the values.
How do they really simulate, or are they doing some like evolution algorithm stuff to figure out what works best? Or?
So the question was, how do they do it? If it's simulation or evolution algorithm, answer is yes, they do both. There was a question there in the back.
Is there a scenario where the trust drops so low that a car can't get back to a higher trust because everyone's avoiding it like for 2 kilometers or something like that? Can this happen?
Yeah, so the question was, what happens if it can happen if the trust drops to zero and basically the car becomes immobile? I think it's a variation of the question that already happened. It really depends on how much you factor in reputation. And in our research, reputation shouldn't be that high factor. It's just one of the many. Main is the scenario 3, and that's from past experience with that between the two actors. That's the main factor always.
There's an error in that diagram.
Yes?
Below the other lane available, you've got the yes and no swap.
Which one?
Other lane available.
Yes, yes, yes.
The yes should be no, the no should be yes.
Yes, you're right. So there is a... Unfortunately, the student who did it already graduated, so... Yes?
Is there any mechanism to share the trust evaluation between the cars?
So the question is if there is any mechanism to share. Yes, it's called reputation. We were talking about it. Basically, it's part of the trust management. Daniel? Sorry.
I think there is like a lot of potential in improving the efficiency of transportation with that. So do you have any estimates how much better like the overall flow will get by that, by using that?
Yeah, so the question was how much better the flow would get if I have any estimations. I don't, but my student had, and I think the average was like 30% in like smaller situations in metrics, but it doesn't really tell you anything. You need to actually try it on real world data, and that's hard to hunt down. But I expect that it will be better, yes. If the trust is high. If nobody trusts nobody, then it would be less efficient but safer. There was a question?
If you share reputation and we stay at the example of cars, do you also include some like official data like accident statistics or something like this, that this type of car, like Ferrari, normally drives faster than a Fiat or such thing?
Yeah, so if there is any other information contextual to the reputation. The reputation comes from other vehicles, so it doesn't really make sense. You have the digital twin of the Ferrari, and you can simulate the Ferrari and the other vehicle will know that it goes fast. So you don't need this. Yes?
Yeah, hypothetically, how would it work if someone, a human, compromised one of the vehicles and started sending altered models to the other vehicles? So you basically lie about this component.
I like this. I like this guy.
It's basically a problem with reputation.
Mhm.
Get to the network, and meaning that the compromised vehicle would be like stretched away from everything.
Okay, so the question is what happens if somebody tampers with the model or the model is dishonest, right? Yeah, if the model is dishonest, the compliance will be lower because it behaves differently than in real life, and the trust score will be lower. So it will be cast out, yes. If you are dishonest, we don't trust you. That's the point.
Yeah, but you mentioned that it behaves in real life, but it also takes the information from the sensors, from the model that the compromised vehicle sends. So like,
No. You only get from the compromised vehicle, you get the model. And then you observe the behavior of the compromised vehicle and you compare the simulated, that you simulated with the compromised model and what happens in the real world. And between the divergence is too high, so you don't trust it. Same as with humans. If I start doing back saltos here, you would be suspicious of me because your mental model of me right now isn't about doing backflips until now. Matthias?
How does this deal with mixed traffic with both humans and autonomous?
So how does this deal with mixed traffic and humans? It doesn't.
Is it a problem?
Not necessarily. You can have, basically we can deal with vehicles that don't share trust, but they might be less efficient. You know, like using an Apple phone with an Android, with a Linux computer. You know it probably. It's not that fun. Yes?
Is all that information about the models stored in each car, or is constant connection?
Yeah, so if all the models are stored in each car, well, it would be very inefficient, and I go back to the first question of Magnus, what do we store? If we only have like a bunch of security guarantees, then the model can be actually really small, because you just have a bunch of ifs that the simulation behaves on. On the other hand, do we want to put a price tag on efficiency and these kind of stuff over safety? Do you answer your question?
My problem is more what happens when the connection is lost.
Do you think, okay, so what happens when the connection's lost? Do you think that the new autonomous vehicles would behave now if the connection's lost? This is a problem that I'm avoiding because I assume that this is already sorted problem and one step forward trying to solve the problem comes after. So yes, I'm not dealing with that, thank God. Yes, sir? Okay, so yeah, I understand. So the question is if the computation power is worth it, and if we have enough for it, and if it couldn't be centralized instead on the level of the city. First of all, the city doesn't necessarily want to have this responsibility. On the other hand, you can play Witcher 3 on Teslas. So it has enough. The new cars have, they are basically smartphones and supercomputers on wheels. There is enough computation power on it. And again, we cannot put price tag on safety, especially that all the safety ISO standards are very rigid. You cannot really bend them. And in these situations, when you have autonomous vehicles and they can join and leave the network, you have a lot of unpredictable scenarios. There is something new needed, a new approach to safety that's not based on only on fixed standards. Obviously, the standards should be there, but you need to have this wiggle room with the decision tree that allows, if the trust is higher, to move things smoother, and on the other hand, if it's lower, to be more careful. Carefulness as a service. The question was if the cars share the trust factor with other cars. Question was there already. Reputation, yes. Yeah, it's just not called trust. Whenever you send the trust to somebody, it's already reputation, or as I like to call it, gossip. There is also the problem of, I'm on record, shit talking about other cars. So it's also a valid problem, and there are also mitigation techniques for that I am not researching, but I know that some others do. And it's actually similar to human psychology, so the research is really close to that. That's all I know about it. So you were like looking for traffic police. There is also research in our lab on that, and I was speaking about it 2 years ago. I don't have a QR code for, sorry. We can actually run agents issued by the city that take over the car, basically, and those agents are basically in the role of the police, enforcing speed, for example. And my presentation then was about how to do it safely. But nice that you come to the same conclusions as I did. Any other questions? We still have 5 minutes, please. It would be very awkward. Yes, Honza?
What should be the next step? How to do it
So Honza is asking what should be the next step. For me, the next step is to graduate, but for for the project, we have some collaborations with industry and with some research institutes in Germany that work with digital twins. So there are actually efforts to try this in real life, on real cars, not just simulations. I think I sent you some videos in cars. Go ahead. Yeah, so the question is about how can we trust the trust from others? Well, you have a trust score for the car that sends you the trust. There is this thing called multiplication. It works pretty well. I was surprised that this is a dumb solution that just multiply the trust of the others, how much to factor it into the weighted average, but it's genius, it works. It's that damn simple. Magnus is shocked. Any other questions? William?
How do you make sure that safety isn't compromised on high trustworthy situations? Like you mentioned that when some high trustworthy can go faster, how do you don't compromise the safety to not have life lost?
Yes, so William is asking about how to handle when, let's say theoretically, a vehicle is gaining much trust and then goes crazy, right? Ideally, the digital twin should model this, but there is no 100% guarantee that this will be avoided. That's why we have the trust score between 0 and 100. And in my opinion, it never should go to that high. Like 99.999 something, fine, but 100, that's like yourself is the 100. Everything else is, it's like when in high school the teacher tells you that only God can know it for A and he can know it for B and C is your mark. Same thing. Did I answer a question? I know they are, but you cannot find them, so the slides are available. It was hard to find them. Okay. So you should be able to find the ones from 2023 as well. There are the police stuff. Okay. Any other questions? I really love these discussions. Thank you for the feedback. I'm going to use it in my research. If you want to talk to me, I will be at the party. Thank you.